All right, guys, we're going to move on to equations. So we had expressions earlier, and now we have equations. Equations are going to include an equation. We'll have an equal sign. Okay, so you got the equal sign in there, equal sign. Okay, so these are expressions, which are great, but these are equal signs, equations with equal signs, which are even better. So you got an equal sign here, and it's pretty powerful stuff. What you're saying is whatever's over here is the same as that, right? So if I said 2 is equal to 1 plus 1, you would agree, okay? But we're going to throw in variables in here, so we're going to say something like this. Something plus 1 is equal to 2. So what's that? And we're going to solve that. You might say, oh, that's easy, that's 1. But we're going to go through and we're going to find variables. We're going to solve. Solve is to find the value of a variable that makes it true. To do that, we isolate, which means at the end we're going to have something like x equals something. Okay, so you isolate means leave x or the variable by itself, whatever variable it is, usually x, but it doesn't have to be. And you get everything on the other side of the equal sign, and then you say x equals blank. Okay, and then here you must always keep the equation equal. So the equal sign is a big deal, right? So when we go through this, we try to line our work up with the equal sign in the same spot. And as we move down, this is always going to be the same as this. This is always going to be the same as that. We're going to use that power to get us through. So these are the questions we did in class, the ones in our notes. We have 8 equals a plus 3. So something plus 3 is 8. And you probably could figure out that that's 5. Do that in your head. But the way we do that in the one-step equations is all you're going to do is you're going to isolate by performing the opposite operation. So here I have my variable a on one side of the equal sign. It doesn't matter what side it's on. If it was a equals something, that's what we're more used to. But something equals a is the same thing. Okay, so in this case here, the a is on the right side, so we're going to leave it there. What's happening is this 3 is adding to it, and to get rid of this 3, because we want to isolate and just have a by itself, what we do is we subtract 3 from both sides. Okay, so you want to get rid of this. It's what we call the zero principle. You have 3 here. I want to get this out of here. So what I do is I subtract 3 from this side, and you say you can't do that. Well, I can if I do the same thing on the other side of the equal sign. So over here, I'm doing the same thing. I got 8 minus 3 now. And I have a plus 3 minus 3. This turns into 0, so I just have a. This turns into 5. I'm done. Okay? So you perform the opposite operation. We're going to speed up eventually, and what I like to get to the point, and hopefully you're good with this at this point after our lesson today, is to say, what is the 3 doing on this side? Well, it has to do the opposite thing when we bring it across. So what I would like to do is skip all this. And then if I have a plus 3 equals 8, what I'm going to do is get rid of the 3, bring it across the equal sign, ask yourself, what is it doing to the a? It's adding on this side. On the opposite side of the equal sign, it has to do the opposite operation. So it was adding, now it's subtracting, and then you clean it up and solve like that. Okay, if you use that technique, we don't have to here, but let's go slowly first, and then we'll speed it up. The 7 is on the left here beside the variable. To get rid of the 7, what we'll do is we'll divide by 7. Okay, so it's multiplying on this side. To get rid of it, we'll divide by 7. So we have 7 over 7 equals 1. That's fine as long as we divide by 7 on this side, which is what we do when we get 5. But the quicker way, 7's multiplying, bring it across, have it divide. So instead of doing everything, if this is all the steps, there's 7p equals 35. P equals 35 over 7, and that's 5. Okay, what we do later is we check, and what you can do is you sub in to check. You sub in your answer into the equation. So 7 times 5 is 35. 7 times 5 is 35, so I'm happy. Okay, we'll get into that a bit more. So you just do the opposite operation. Here I'm subtracting. To bring it across, I add. So I would just go into y equals 14 plus 1. Y is 15. Okay, but if you want to do each step, you can to show all the work. But again, at some point, hopefully you get to the point where you're just bringing whatever's on the side of the variable, you bring it across by performing the opposite operation. Okay, 2-step equations, you do the same thing. Okay, you're going to do the opposite operation, but you're going to add or subtract first and then multiply or divide. So another way to think of it is start as far away from the variable as possible. So here's the plus 1. What I'm going to do here is I'm going to bring it across. So 4x equals 17 minus 1, because it was adding to the 4, sorry, to the 4x. So now when I bring it across, I have 4x equals 16. Then you have a simple question here, 4x equals 16. Bring that 4 across, it was multiplying, so it divides. 16 divided by 4 is 4. And then all the other questions are similar. Just be careful on this one here. You might say, what's going on here? What's this minus 6 doing? So one way to think about it is bring it over here. It's the same question, right? You just bring it here, and then it's obvious what it's doing to the b. It's subtracting from the b. So when you bring that across, you're going to add. So take care of the adding and subtracting first, and then here you have 10 equals b over 2. The 2 is dividing. Bring it across, multiply, and you're done. So again, we looked at checking. Checking we get into a little bit later here, but let's go back to this question here. So here I have 4, my initial equation was 4 is equal to negative 6 plus b over 2. To perform a check, what we do is we do a left side right side check, or left hand right hand check. Maybe not left hand, right hand, I might have made that up. So what you do is you say the left hand is 4, left side is 4, the right side is minus 6 plus, and we said that b is 20. So we're going to sub in our answer. So our answer was 20. We're going to sub that into the equation. And we have 4 equals minus 6 plus 10. 4, left side is always 4. You don't have to write it every time. You can just leave it up top. And minus 6 plus 4 is 4. So you get to the point where whatever's on the left is the same as what's on the right. And if that's the case, then your answer was right. Okay. If it's not, you either made a mistake getting your answer, or, to tell you the truth, a lot of times you're more likely to actually have a mistake in your substitution here, in your check. So be careful on that. Okay, so that's single step, two-step. Multi-step, what you're essentially doing is collecting like terms first. Okay, so the first couple questions we do here, all you're going to do is clean this up and collect like terms. I have 5x, I have minus 3x, I end up with 2x. So now that's just a question that you had earlier where you have 2x plus 2 equals 8. This 2 is adding, so you bring it across by subtracting. Then you have 2x equals 6. The 2 in front of the x is multiplying the x. Bring it across, you divide, you end up with 3. Okay, you perform a check if you feel like it. Same question here, collect like terms. Where it gets a little confusing is where you have variables on both sides of the equation. Okay, so you have there's on both sides of the equal sign also. And what you're going to do here is you're going to collect like terms, but you have to just be a little bit careful. This is a little different. You're bringing this 2x over here, so it was adding on this side, and when you bring it over, it'll subtract. Okay, so when you bring the 2x to collect the like term beside the 3x, you bring it across the equal sign here, and you have to perform the opposite operation. Adding turns to subtraction. This guy here is adding, so I bring this across here and I subtract, and I end up with this row here. Okay. If I did it the other way around, just to check, I could have brought the 3x over. So I had 2x on this side. If I bring the 3x over, I'm going to subtract that, and then I end up with 2, and I bring that negative 4 over, I end up with that. So I end up with this. So here I have 6 equals minus 1x. I'd have this negative 1 multiplying with the x, so I have to divide. So 6 divided by negative 1 is negative 6, and I get the same answer. So it doesn't matter which side you bring it on, you get the same thing. Okay. So over here again, that negative 2, I'm going to bring the x on this side. You can choose which side to bring it on, whatever you think's going to be easier. So I bring that minus 5x over here. And when you do that, you get minus 2x plus 5x equals 8 minus 7, because you bring that 7 over here, and it was adding, so it subtracts. You end up with 3x equals 1, which is a third, and that's a bit of a pain when you do your check, but if you do your check, you will get the same thing. Okay. A lot of questions the same. Then we get to questions with brackets. Same thing, but you're going to have to open the bracket first. Okay, so you're going to open the bracket by multiplying everything in front of the bracket by what's inside the bracket, everything in the bracket by what's outside the bracket. So 5x times 5 is 25x, minus 13 times 5 is minus 65. And then I have an equation that has variables on both sides. Bring that 23x over. You're going to subtract. So 25 subtract 23 is 2. Leave that 13 here. Bring that 65 over. You end up with that. Divide by 2, 26. Okay, I'm going to leave this word problem for a second. We can look at it later in class again. But the last thing I just want to do real quick is the fraction questions. Sorry. And fraction questions are very easy if you have one fraction, okay? But what we have to do is get rid of this number down here. And it's simple because at this point right here, this is a fraction, but it's not really. Well, I could ask you this: what's this 3 doing to the bracket, right, or to the x? And what it is doing here is it's dividing. Okay. But in general, if you see something that looks like this, let's deal with it as a fraction. And what you're going to do is multiply by the denominator. Okay, both sides by the denominator. So here, what I would do is multiply this side by 3 and this side by 3. And when that happens, these 3 cancel out, and I end up with x plus 8 equals 6 times 3, which is 18. So you can just get rid of this 3 essentially. I mean, in the long run, what would be nice too is if you could think about cross multiplying, or just bringing this up here and saying, if the 3 is dividing, why don't I just multiply, bring it across and multiply? And that's what you're doing, but you can do it in 2 steps here. And then here, I got a 5 on the bottom here. What I'll do is I'll multiply this side by 5 and this side by 5. And when you do that, these 5s cross out, and you end up with 4 times 5, which is 20 on this side. So again, you could take this 5 and picture just bringing it across the equal sign from the bottom of the equal sign across to the top. So often I do that with fractions, is if you have a number here and an equal sign, you can bring it over here, and essentially when you multiply both sides by this number, you're essentially taking it from the bottom and dragging it across to the top. Okay, that's it's not magic. It's just when you do what we said here, multiply by the denominator on both sides, you end up with this happening. Okay, the toughest questions by far are where you have 2 fractions and the fractions are not the same denominator. And there's a couple of ways to do this. The easiest way probably is just to multiply both sides by the lowest common multiple. So here I say, what's the lowest common multiple of 3 and 6? So to find the lowest common multiple, what you do is you take the bigger of the 2 numbers and you start finding multiples of that and ask yourself, is the small one a divisor of that? So for example, I did this over here where I said 6, I actually did it backwards, but what you do is go ask yourself this: does 3 go into 6? Well, it does, so we're done. Okay, but if it didn't, which we'll see over here, you'll just keep adding 4s here until you get something that is divisible by 3. So let's just do this one first. So the lowest common multiple of 3 and 6 is 6. Sorry, a news flash just popped up here on my computer. Just read it. Not that important. Anyway, so 6 lowest common multiple. So I'm going to multiply both sides by 6. When I do that on the left, I end up with 6 over 3, and that reduces down to 2. Okay, so 6 divided by 3 is 2. And on this side, I have 6 and 6, and they'll reduce down to 1, which just leaves me with x plus 8 on the right side. So I have 2 times this bracket and 1 times this bracket. I open up the bracket, so multiply everything by what's in front of the bracket. So this times this is 2x, this times this is 4, this is 1, this is 8. I end up with this, and then I solve. Okay, bring this x across, bring that 4 across, end up with x equals 4. This is the toughest question that we've done all year, I'd say, is when you have this sort of thing here, where you have a 3 and a 4. So what you do here is you find the multiples of 4, and you go 4, 8, 12, and the multiples of 3, 3, 6, 9, 12, and then you stop when they're the same. Another way to do it is to just go like this and say 4, the multiples of 4 are 4, and 3 doesn't go into 4. 8, 3 doesn't go into 8. 12, 3 does go into 12, and you're done. You could do it the other way around too. You could use the multiples of 3. It's easier if you use the big number, but it's up to you. Once you get that, you're going to multiply both sides by 12. So now I have 12 times this and 12 times that, and now you got to reduce your fraction. So you say to yourself, what's 12? You could even picture it like this: 12 times 1 over 3, and that reduces down to 4, because 3 goes into 12 4 times, and 3 goes into 3 1 time. Clean the whole thing up, you end up with 4. Here I have 12 times 3 divided by 4. So here and here, this will be 3, this will be 1. Okay, so that's one way to do it, and then you go ahead and you work your way through. Another way to do it is to actually kind of just drag these denominators across. Okay, so you end up in the same spot, and I just want to show you that right here. Once I reduce here, this was a 4 on this side, and this was a 3 on this side. Once you reduce the fraction by dividing by 12, what you end up with is a 4 on this side and a 3 on this side. So what's on the bottom of the fraction here comes across and is on the top here, and what's on the bottom